Hello friends, welcome again. So today we'll be solving a problem related to bode plot, and the problem is a bode plot is shown to us and we are asked what is the transfer function which corresponds to this bode plot. Okay, so you can observe here that the bode plot has a magnitude which does not vary with frequency. It is a constant value at 0 dB. Okay, and the phase starts at 0 degree and it ends at minus 180 degrees. Okay, so let us proceed. And here what I've done is I've made a table for each of the transfer function given to us, and I have tried to make the magnitude and phase plot, okay, for each of them. Okay, so let's start with option D. Okay, so for option D, which is 1 over uh, s into s plus 1 whole squared, the magnitude is 1 by omega into 1 plus omega squared. Okay, and the phase is minus 90 minus twice tan inverse of omega. So you can see here that the magnitude is varying with frequency, so we don't want that, so the magnitude should be constant, so we can discard option D. Also you can observe one more thing here, that the magnitude, the phase starts from minus 90 degrees, and if you put omega equals to infinity, so it ends at minus 270 degrees. Okay, so this can't be an option because we want our magnitude to be our phase to be from 0 to minus 180 degrees, so D can be discarded. Okay, so D is not the correct answer. Now let's go to option C. Option C says that the transfer function is 1 over 1 plus s, which corresponds to a magnitude of 1 over under root 1 plus omega square, and a phase response of tan inverse of minus tan inverse of omega. Okay, so again you can see here that the magnitude is dependent on the frequency, so here the magnitude will change with time. So this is also not the correct option, so C also can be discarded. Okay, also you can see that the phase starts from 0 degrees and it ends at 90 degrees, minus 90 degrees. So it starts at 0 and ends at minus 90 degrees, so again C is not the option, so C is also to be discarded. Now we go for option B. Option B, if you see, the transfer function is 1 over s plus 1 whole squared. Okay, which corresponds to a magnitude of 1 over 1 plus omega squared. Okay, and a phase response of minus 2 tan inverse of omega. Okay, now you can see here that the phase starts from 0. Okay, and it ends at minus 180 degree. Okay, so phase condition is satisfied, but again you see here that the magnitude again is dependent on frequency. So here again this is not the correct option because the magnitude is going to fall with respect to the rise in frequency, so this is not the correct answer. So B is also not a correct answer. Now let us say we go for option A. Okay, so this is the correct answer. Why it is correct answer? Because if you see here, for option A, the transfer function is 1 minus s over 1 plus s. If you plot its magnitude plot, it is under root of 1 plus omega squared over 1 plus omega squared, which corresponds to 1. Okay, the magnitude is 1 everywhere, or which is a constant. Okay, and 1 corresponds to 0 dB because we have 20 log of 1, so log of 1 base 10 will be 0, so it is 0 dBs. So this corresponds to this uh, plot. Okay, now you can see that the phase also is varying as minus tan inverse of omega, which will go from 0 to minus 180 degree as the frequency is varied. Okay, now how to how to find the phase for this? See, just write the transfer function as 1 minus j omega over 1 plus j omega. Now this you can consider a complex number which is lying on fourth quadrant because omega is negative. Okay, this is minus j omega axis and this is j omega, so the complex number lies somewhere here, so it contributes to minus tan inverse of omega, and already this contributes to tan inverse of omega, but in minus, so this is also minus tan inverse of omega, so it is minus tan inverse of uh, 2 tan inverse of omega. Okay, hence we get the phase as minus 2 tan inverse of omega, so this is the correct option. Okay, so A is the correct option for this question. Okay, so this is how you need to solve for the problems where you can use the options and eliminate. Okay, So thanks for watching.